All right, thanks everyone for coming along today. So today we've got a very special guest, Peter Anderson from the Simon Fraser University in Canada, if I'm not mistaken.
Correct.
And he's come down and he's going to give us a talk about the evolution of ICT and disaster management. So can we give a big hand? Peter.
Thank you very much. Well, thank you very much. I'm going to give you I'm going to rush through actually a number of slides, but just a bit of my own background. I'm an associate professor in the School of Communication at Simon Fraser University. We're more of a social science-based program. For myself, I've been involved in the social application of communication technology for a number of decades. And it was, I guess, probably through work in the late 70s involved in a project in South Sudan of actually trying to look at use of VHF and HF radio to link communities that drew me more into the disaster management area, particularly looking at, so it was right at the end of a long civil war, which unfortunately resumed 4 years later. So, but over the years, I've been, I guess in some ways, privileged to be able to participate in a lot of different projects and programs. And a lot of my work over the years is focused on looking at ways to improve information exchange, essentially between people who have knowledge about hazards and their properties and those who ultimately have to deal with their consequences. So it's a very broad area. So just in terms of international work, I've been able to work in a number of different countries and regions over the years. In terms of the disaster management area, I've worked directly with the disaster management organizations during events and continue to today. These are just some examples. Some of these are ones that you wouldn't recognize, but these are from the, I guess, basically mid-1980s into the present time today. And then within British Columbia, I work extensively with our emergency and disaster management organizations. And one of the functions that I called upon is I'm often called in to help to do the risk assessment on the critical communication infrastructures that are being impacted or could be impacted by a particular type of hazard. Could be wildfires, floods, earthquakes, and we also design and develop systems to support operations, which I'll give you some examples in that. And I also, my actual formal, more academic area has been in policy and regulation, telecommunications, broadcasting policy and regulations, and we've done also a lot of background studies on looking, for example, in the 1990s, the emergence of mobile telephone systems and the implications for their use or dependency during emergencies, to doing studies on tsunami warning systems, as well as working with communities on helping them in methods for improving warning systems and that. I also teach senior undergraduate courses in policy, as well as some special courses in the disaster risk reduction area, and also supervise graduate students in this area. So just, this is a bit of a personal history, but a lot of it coincides with the emergence or developments of ICT over the years, and some of the early projects I got started in late 1990s with the development of personal computers. Started experimenting with the use of computer bulletin board software as an attempt to find a common meeting place for people interested in emergency management planning as a way of sharing information. And where we look at where we are today, it's hard to believe that people in those days had never communicated using computers. Even the idea of using personal computers to store information in some organized way was still in very early stages of development. So I received funding from our national emergency management program and established the first system. It was called the Emergency Preparedness Information Exchange, basically a store and forward system. And it was all text-based at the time, had a hierarchy of menus, but it was really one of the first ways that organizations could start to share information, as I say, store and forward, but this whole idea of being able to link up to a system on a 24/7, 365-day basis was entirely new. Up to that point, people communicated using facsimile machines or telephones or whatever means they could. In fact, telex was still, at that point, as considered a very viable interchange technology. So this became, as a prototype, actually quite successful nationally. And in 1989, I moved to Australia, to Melbourne, and worked at a new communication research center, and was encouraged to continue working on this. So we took this prototype, and I worked with the Australian disaster management community, starting in the state of Victoria. Over a 3-year period, we built a statewide network. It was called the Australian Disaster Management Information Network. And we started in the state of Victoria. We worked with the state emergency services and police, Country Fire Authority, Metropolitan, other groups, and established the first network. Our center and the Australian Disaster Management Training Program, which was located in Mount Macedon, we acted as the central nodes to link up, and we worked with each of the agencies to establish their own nodes, and they developed their own sub-networks to link to their regional offices. And this was the first time many of them ever actually worked together. And the whole idea of sharing information and establishing the trust was quite important. But each of them gained some benefit internally, but also the idea of being able to share information across the network was really important. For the content, each group had to, as their domain specialists, had to contribute one layer of content. But to become part of the network, you had to also agree to carry the core elements of the network, plus you could supplement it with your own. So this was the first time the groups actually got a view of the bigger picture. They could see where they were represented in the operations, but as well, they began to learn about what others were doing in the field. So this was between 1989 and 92, and then during that process, each of the agencies worked with their counterparts in other states. So State Emergency Service in Victoria worked with New South Wales, Queensland, etc., and they established a horizontal network, but was all linked in. So we used basically standard bulletin board software, but it was all addressable. It was basically pretty much same model that the internet was based on. Instead of IP addresses, we had each node had their own unique address, and we had a way of being able to move messages across. We also started to build gateways to other networks, and in particular to the United Nations, so that disaster situation reports that affected the South Pacific Island areas, the Australian agencies could get access to that information. They're also playing a response support role in some of those communities as well. So this was up to 94. Then, of course, the internet was emerging. So this network, as it existed, doesn't exist today. Of course, people have transitioned. During that period, I moved back to Canada and back to Simon Fraser University, and I moved all of my work onto the internet. So I set up one of the first sites on the internet. We transitioned over, and the system, Emergency Preparedness Information, we used a Gopher service technology. Anybody know about Gopher? Thank you. At least there's somebody here. It was actually developed at University of Minnesota. Gopher was their mascot, but also what was unique about that, of course, was gophers tunnel underneath and they come up at different sites. And essentially, this was the first concept of being able to organize content on the internet rather than telnetting to a server and trying to look at it. This was one of the first systematic ways of organizing content and making it accessible. So whether it was stored locally or through links, through hyperlinks. And so we transitioned over, but we also put into place gateways so people on other networks could come in and access the system. So again, it was very similar to the bulletin board. It's hierarchical, but in this particular case, the project became extremely successful internationally. We became really the sort of the portal or the gateway as it developed. What was nice too was that just from the logs of connecting, we could actually see how the world was connecting onto the internet. Every week, we'd have new connections onto our site, and we would see they were coming from countries that had just established their first connections onto the internet. So it was kind of an interesting way of seeing how the networks were emerging. Some countries didn't have network connections. They had to use a dial-up connection to another country, and we assisted them in facilitating access so they could dial up. So it became, as I say, quite successful as a catalyst for driving interest in this. And so we moved not just from developing our own services to helping others. Universities were among the few that had these resources and connections. Many governments, other programs did not have internet. So we started to work with a number of groups. Examples I mentioned with the UN. I worked with the UN Disaster Relief Office, and we set up the first email gateway to distribute all of their disaster situation and reports and appeals for assistance. And we ran that for 10 years, actually. They were using facsimile. They had 3 fax lines that they would spend all night sending out the situation reports and appeals, and then probably about 5 o'clock in the morning, they would have to go down to 2 machines and then leave 1 machine open for receipt of faxes coming back from donors and response agencies. And then, of course, in the midst of that, the situation would change, and they were trying to get revisions out. And so, we were able to help by getting onto an email list, and as agencies connected onto the internet, 1 message was equal to them spending perhaps upwards to 2 days to try to get the information out. There were special UN programs. The International Decade for Natural Disaster Reduction was a 10-year program that we hosted the service for, but this was an opportunity for us to work with agencies on looking at the role of information exchange and information technology. So we undertook a lot of demonstration projects through that time. Also provided a mirror site for a lot of discussions, email discussion groups. And also, even during events, the Northridge earthquake in California, their server that they were using within California for their state agencies was congested, so we became the backup site for them, and you had to telnet into their site, and we actually were able to take their data and use it through our Gopher site, make it a lot more accessible. It was also a way of drawing the public away from their site and providing an alternate source of information. So this was during the Northridge earthquake. I mean, the number of messages are really small compared to today, but these are all the situation reports from the agencies, the transportation, health, and so on, that were reporting internally. And of course, we had archived all that information. As the World Wide Web came along, of course, we moved over. I mean, you look at the design today compared to, in terms of styles, but you have to look back at those days. Even compression techniques for images were just evolving, and how you design your website. If you're on a slow dial-up link, it could take 10 minutes to download the front, the home page if it wasn't designed carefully. But we started to work with a number of agencies, and we became either a collaborator or host. These are sites that we developed and managed on behalf of organizations. Eventually, we transitioned over. These were UN programs. This was the first attempts to provide response support for UN operations, as well as the HazardNet was the first attempts to actually provide access to hazard event information. We were trying to get towards near or real-time hazard event information, so I worked with U.S. National Weather Service and UN Environment Program and others. And as I say, when we look at today, what you can just pick up on your smartphone and correlate, we were just at the very baby step stage in those days. This all became what's called Relief Web today. If you go on, it's a very, very comprehensive site. But these are samples of this organizations that we helped develop, host, and in many cases manage. These included our National Emergency Management Program, our Provincial British Columbia Program, and we managed these through actual events. I was the webmaster quite often during major events. So I would be sitting up all nights at my computer at home, sometimes getting information posted. So a lot of this was for supporting planning. It did get used during real events, but we also started to realize that if agencies were adopting IP-based communication, this offered a level of or type of interoperability that we could have never really dreamed of before. And particularly in disasters where you end up in a situation where emergency managers necessarily can't get to the places that they need to be at, or don't have to be there but need to provide expert opinion or advice or input. So we started to experiment with this idea of virtual emergency management information systems. And the idea was to enable critical emergency managers to remain in critical decision-making processes regardless of where they were located. And so as part of this, there was no commercial wireless technology on the market yet. So I worked with a couple of microwave engineers they actually designed IP radios. We used amateur radio 400 megahertz band, and we built our own IP network. And we put up 2 radio repeaters on strategic locations in the greater Vancouver area. One was with our broadcasting, national broadcaster, another was with our electrical utility. So we had coverage over around 120 to 150 kilometers. And the gateway was back at SFU in our computing center. So wherever you could see those sites. So these sites here, this is the actual modem and radio. It's a Linux box, which was used as a router and as a 386 computer. And the little Macintosh box, I had a server on there. I called it Web on the Go, out of the back of my Forerunner, and which was running off of an inverter. And anywhere we could see the repeaters and link to, we could communicate. And of course, that server would be accessible anywhere in the world where somebody had a connection. So we started working with federal departments and other agencies as a way of being able to position this at a site or even in a rural area that had no connectivity, and even at their desks, they could from their desktop computers, they would be able to access information. So this was the start of a project. So these are the repeater sites, and so essentially it was a point-to-point and a multi-point system. And then through that, we worked with the federal government's research center, and they provided us with VSAT ground stations. The idea we could link our system by satellite with the connection being across Canada in Ottawa. So if we had a major earthquake in Vancouver and we lost our connectivity, we could regain access through the satellite link through interconnecting in Ottawa. And vice versa, Ottawa is actually a seismically high-risk area, so a lot of people don't realize that. So if they lost connectivity, we could become an alternate link for those. So these are really early stages. This is mid-1990s, I guess. We were starting to do this. And so we established that framework. And then my research lab acquired a set of ground stations in a research park adjacent to us, which we retain today, and provides us with our own teleport facilities. We have fiber optic cable connections right back into the main university and academic networks. So through this, we in terms of progression, we started to work with search and rescue groups, actually looking at placement of a VSAT station in a remote area to provide connectivity. As Wi-Fi started to come onto the market, we started to work with search and rescue teams, so setting up hotspots where they stage their searches from so they could drive their vehicle up, and as soon as they're at that spot, they were connected. In some cases, there was a commercial connection, but we could also provide a broadband link from our university that's strategically located on a mountain, central spot in the Lower Mainland. We could shoot it across over to a mountain and establish an alternate internet connection for them. As we moved away from analog to digital mobile phones, we started experimenting with use of WAP technology and developing databases, for example, dangerous goods or hazardous materials that you could access a database and put in a placard number for the that you'd see on a transportation, a container or whatever, and it would give you the information about the hazard and whether it was inhalable, how far away you should be, et cetera. So we started experimenting with PDAs, and through this, it led to working with our Forestry Service, European Space Agency, and some others on looking at real-time access via satellite for supporting wildfire response, and being able to provide handheld terminals to firefighters or the people at the incident command. And we're also looking at being able to access remote sensing, satellite technology, and so on. And so these are some of the prototypes. So, it's what I look at today. If you look down the left-hand corner here, this is GPS connected to, I think it was a VHF or UHF radio with a PDA attached to it, and so on. And so all of that with the antenna that's duct taped together, is probably 2 or 3 components now that's sitting inside one of these. So this wasn't that long ago, at least from my experience, but just gives you an idea of how rapidly we've been moving along. So, in 2003, is coming up to our 10th year, we had one of our worst fire seasons on record. We had in the central interior over 400 active fires, and many of these were huge. They were over 25,000 hectares. And we were looking to have to evacuate hundreds of thousands of people from several cities. And to give you an idea of the personnel that's brought in, this is just an example of how many people from different jurisdictions, agencies, and we had to coordinate this, and we had to provide situational awareness. It had to be timed in order to evacuate communities. We had to have proper routes in place, and this is where the role of the internet really came into place. This was looking at linking the different emergency operations centers. The one on the bottom left is a provincial central coordinating center. These are 2 local authorities, this one and this one here, and then this is a provincial regional emergency operations center that acted as the regional hub for these communities, and then Victoria acted as the provincial support center. And of course, if you look around the room, what you see are computers everywhere. 2 years earlier would have been paper maps, just all kinds of non-standard ways of trying to exchange information. But what supports all of this, of course, is critical infrastructure. And typically above a community, this is what you would find. This is a wireless internet, the cable TV, television transmitters, a critical microwave relay for telecommunications. A lot of all of the critical assets that support the community are on there. But, of course, this was the kinds of conditions we were dealing with fires coming over these hills. And before you were to evacuate the community, the fires would roll over the hill, or there was a risk, and destroy all the infrastructure. These are cell sites, broadcasting sites that were destroyed. And this is even the wireline sides. Some of these pictures, that telephone pole in the middle, it's actually the cables that are holding up what's left of the pole. The bottom base is burnt out. The fires were so strong that even the fiber cable underneath that was buried was melted by the fires. They lost power lines, power and telecommunications. We lost about 160 kilometers of telecommunications infrastructure that summer. So my job ended up as having to identify the risk of the fires for these communities and try to work with the carriers and others to either anticipate loss or to look at what we needed to ensure that we had still remaining some lifeline communications. So one of the first things that we were able to we started to map infrastructure. And so where these concentric lines are, you can see these red lines, that's the fire perimeter. And so what I was able to do was look 10, 20, 30 kilometers out at what was at risk. All these green dots are all critical radio sites or cellular or public safety sites. And so we were able to, as the fires were progressing, look at what was going to happen next. I mentioned we also hosted the province's website at the time. So this is some examples of the traffic. We're actually getting about 1.5 million hits a day, which by today's standards is probably pretty small, but in those days, that was significant traffic. This was one of the first occasions where the province could communicate directly with the public and provide information. Up to that point, it was usually done just through traditional standard media. And so from a social media perspective, this became really important. So, since that time, we continue to do work. So we work on, critical infrastructure planning and reduction. This is a railway slide, or a rock slide over railway tracks on a highway. This was the Sea to Sky Highway, which leads up to Whistler. This is 1 year before the Olympics opened, and they just laid new fiber optic cable along the rail bed, and which was also carrying all of the emergency traffic for your 111 service and that. It turned out the fiber was still operating, but we now are worried that as they remove the debris, these rocks, by the way, some of these are larger than size of these large shipping containers. So we had to make sure that if they damaged the fiber while they were removing the rock, that we had an alternative. So we had to work with the telecommunications industry to find another route.
Was there any link between the laying of the fiber and the rock slide?
No. Now this is it's a geological hazard that's always there. Even during the Olympics, there was possibility of this happening. You could have people up in Whistler, and there was an alternate roadway that you could get in there. But this is quite typical. This is in a canyon. You can see the fiber along there, and that fiber is not just single service. It can be providing national, international traffic. It can have all sorts of things in services in there, which it's people lease or buy extra fibers. Some have redundant fibers elsewhere if the fiber breaks, but in some cases they may not. So we don't always know what services are going to be affected. And then, of course, we're also prone to flooding throughout the province. And I mentioned we have seismic risk and so on. So those are some of the types of hazards. So some of our particular response and work towards this is, particularly after the 2003 fires, as we worked on developing our own mobile communications gateway facility through our lab, which we operate, and it provides power. We have a 20,000 watt diesel generator, so we can provide power and support, and then a full complement of communications systems. So we have everything from, we have a self-aligning VSAT ground station, so that will it takes about 10 minutes, and we acquire a satellite link for our internet access. Our internet connection is in Alberta, so we're not dependent on any infrastructure in British Columbia for that. And then we have a full range of different satellite phones, and plus we have our own voice over IP telephone switch we can support right now. That's configured right now. We've got 32 lines, and we can remote those through an IP link from the vehicle. We have a 10-meter mast with 2.4 and 5.8 gig radio, so we can put a link up to 30 kilometers away from the vehicle, depending on line of sight, and establish a node somewhere else. Or we can get a connection from somewhere else and import it into the truck. We have programmable radios, interoperability switch, so we can do cross-frequency connections. So if we have fire departments that are brought together that are operating on different radio frequencies or different services, we're pre-authorized to program a lot of their radio frequencies. So we act as the relay. We can interconnect. And so we've been deployed a lot. We're involved in supporting search and rescue. This was a forest fire threatening a community, and there was no cell phone service or internet access. So we went in there and provided backup support. This one here is in an urban area. It's a warehouse for a major avian influenza outbreak, bird flu, which resulted in tens of millions of chickens that had to be culled, and they needed to quickly set up a joint emergency operations center between federal, provincial, industry, local authorities, and so on. So we were called out on a Sunday morning, and by 2 o'clock in the afternoon, we'd set up basic operations. the trucks parked out there, so we set up a local area network with phones as well as computer access and so on. It took the government agency that was the lead agency. It took them a week to wire up the facility for ongoing operations. So, and then I mentioned we have our own ground station support, so we could remote the truck somewhere else in the province and have our own dedicated links, or we can go out of province. So just a few other examples is we continuously also support direct support to our regional emergency operations center in the Vancouver area. We have one of our campuses about 2 kilometers away, so we have a broadband wireless link to that center from our university. It uses our university network. We provide our phone switch in our truck, as well as portable ones actually connect directly back to our university's telephone network. So our phone switch becomes a branch exchange from the university. We could be deployed anywhere in North America, actually, and we have a good IP connection. We're connected back to the university. You have regular public access phone numbers. It's just that if you're making a call in some remote area, it's a Vancouver number you're calling. So we and our truck is actually staged at that center. This is the center here, and in fact, up on the mast here is the broadband link that goes over to this is our campus in Surrey, one of our 3 campuses. So we have a way of providing. We're in the process now of getting fiber connected there, so we can connect onto our research broadband national and regional research networks as well to provide support. So I'll just quickly go through on some of the other areas we've worked on. Is a particular area of interest. I come from northern British Columbia, from a rural area, so I have a lot of empathy for people in rural and remote areas. But there are also places where it's extremely hard to reach, and actually, so I've always been interested in that. Got involved in British Columbia, but also elsewhere in Sri Lanka right after the tsunami. Was invited to go and work there, and worked initially with a group on a concept paper for a new national early warning system. And a follow-up to that in 2006-2007 was a pilot project to look at the use of different combinations of ICTs in the communities for a new hazard information dissemination system. So we worked with 32 of the tsunami-impacted communities that were at different stages of socioeconomic development, and had the prerequisite was also involved in doing hazard, risk, and vulnerability studies and developing projects. So these were some of the ICTs that we experimented with, fixed CDMA phones, but also with mobile phones with Java software loaded on, so Sinhala, Tamil language scripts could be transmitted in addition to English. Probably the most, there was basically a mobile-based warning system that could trigger a light, sirens, had text messaging. Probably the most innovative, though, was use of satellite radio, World Space system. We also set up a VSAT teleport, but the World Space one, these units, basically you can datacast to, and it's like satellite radio commercial service, but these were modified to enable not only data casting, but the organization we worked with, Sarodia, they had their own audio channel provided, so they could upload messages and content in different languages. They also used a common alerting protocol where they could use meta tags to set which units they wanted to reach. They could do geocoded or sort of by community of interest, and these were placed in the communities. And this is the little receiving antenna, and they could be triggered to turn on, turn off. If somebody was listening to another audio channel, it would bump them over directly. that was one of the projects, and some of the other ones that we've been working on are scalable technologies. So being able to design sort of more grab-and-go packages that you can deploy particularly in remote areas. So in British Columbia or in Canada, we have a mobile satellite system that provides not only for regular telephone dialing, but also has a two-way radio mode. So we have some specialized talk groups set up. So any of the emergency organizations that are subscribers to the service automatically are part of this interoperability talk group. It operates independent of any of the local infrastructure. We also have another group that's a privacy. You can do one-on-one, but we can add other talk groups on top of that. So it can be operated as a mobile or fixed. And so we've been working on this for tsunami warning and and emergency communication in remote areas along our coast. This is one of the coverages, so you can see any of the organizations within that. So our provincial emergency programs, all our regional centers, a lot of the local municipalities now are members of this, as well as ambulance and some of the other services. And then this is more of a mini version of our truck we're working on, which can be towed into an area. We're modifying it. It's aluminum chassis, so we're putting brackets on it so it can actually be helicoptered into an area. So if there's something happen in a remote area or there's damage done to transportation infrastructure, we can move it in. And then some of the examples of smaller grab-and-go systems. This is with a search and rescue group on the table. I don't know how many of you have used BGAN satellite systems, but this is this little device on the table, or that's a little BGAN satellite terminal that provides both IP and telephone service. So, but it's expensive to use. It's $8.50 US a meg, so you have to be careful. You want to make sure all your automatic updates are switched off on your computers and things to start with. But in the middle of nowhere, you get it's about a 480K bidirectional connection. So it's really important, particularly for search teams, to be able to exchange information about where their teams are and so on. So I'll just let's quickly finish up some other projects. So we're working on multi-agency situational awareness systems. This is a national project to enable agencies to share real event and situational awareness. And then some of the other areas we're starting to work in is looking at the interface with social media. So things like crisis mapping and crowdsourcing. How can we use that both for during response, but also as planning tools. So enabling people to do even their own hazards and risk assessments of their areas and have some tools to facilitate that. And then the last piece I'll just put on here is so we work a lot in the disaster management field, but another area that probably seemingly doesn't appear to be have any relationship to it is actually in space exploration. And my colleague who works with me is a physicist, astrophysicist, and we apply these same models and concepts into the design for communications for human space exploration. And there's a site way up in the extreme north of Canada, way up in the Arctic, that's almost just on the edge of being able to use geostationary satellites. It looks like the dish is pointed right into the ground. It's just on the edge. And it has a crater. It's called Houghton Crater. It's about 20 kilometers across and has among the most Mars and lunar type features on Earth. So it's become a major analog site for testing concepts and technologies for space exploration. So this is the site. And so my colleague, he's the chief field engineer. He goes up and establishes, he goes up about a week before everyone else and sets up a communication system. So there's a VSAT ground station to link out of area, and then he builds a broadband wireless network. The tent is where the equipment, the modems, and so on are stored. And then the actual camp is down into the crater. So because the satellite for line of sight, it had to be up on the hill in order to see the satellite, so it's relayed down inside. And about 200 scientists from around the world go up there. It's only for about a 6-week period where the weather permits. And but it's a lot of the NASA centers as well as other researchers go up there. So our lab provides the communication support for that. And we even have this Humvee. This was driven over the ice and to get there, but we can never do it again, actually. With unfortunately with climate change, the ice thickness now won't enable us that same opportunity. And this is my colleague. he's testing out. A lot of his work is involved in looking at interoperability and integration of systems. So from a spacesuit sensor technology or internal communications to relaying that outward. And that's the same kind of requirement that you can have for emergency management. These could be first responders who are trying to relay information, or they could be support staff somewhere in the area. So, and these are some of the current projects that we're working on. There's the federal government has just released a new spectrum for broadband public safety communications. There's in the United States and Canada. This is for mobile broadband use, which will be a separate network from the commercial cellular networks. It's going to be LTE based. And so we just got funding this 2 weeks ago to build one of the first mobile prototype cell sites, which will be included in our truck. And that, so we will continue. So, starting back with bulletin boards 20 years ago, I guess it gives you some ideas, or at least gives you some sense of not so much what we've been doing, but just, we've been following sort of the curve or the wave of technology as it's moved along as well. And so there's certainly an engineering aspect to it, but for me personally, it's also the opportunity to work with a variety of different disciplines and jurisdictions, in its ultimate use. So I'll stop there.
All right, we'll get a big hand. Got a bit of time for questions.
Sure.
So what are you doing in the BC coastal tsunami warning system? I'm particularly interested in this because I have a home in Tofino, right on the beach.
All right. So we can start with Tofino.
Yes, okay.
In fact, one of the pictures there was the Tofino Fire Department. I don't know if you noticed. Actually, in 2003, I did an assessment of the West Coast Tsunami Warning System because I found that since it was built, a lot of the coast has changed socioeconomically and even culturally. There's a lot of different populations there today that weren't there in the past. We have new economic activities. We have fish farms. We have floating logging camps. These do helicopter logging off the shores. And we also have a lot of people who have settled there that weren't there before. The west coast of Vancouver Island and up the coast is also among the most rugged you'll find anywhere in the world, which makes it really difficult to provide reliable communication. Tofino, they lose power regularly, and they lose their telecommunications regularly because it's landline based. And even if you try to use satellite communications, the mountains and the terrain make it very difficult. Marine communications the same. The repeaters for Marine Coast Guard are on the mountain above the town, and they're designed to communicate out into the ocean. So people down are in the shadow areas. So my work has been to look at all of the communication systems that are available along the coast, assess where they can be used, how they can be used, and to look at different combinations for warning with the communities. And I believe you have to, in a place like that, I always say you have to, since 3 layers deep, you have to have at least 3 alternatives that are not dependent on the same infrastructure, because two of them surely will fail for some reason or another. So you try to make sure you have at least a third, but you can't just simply compose a text message and send it off. And in these cases, they're still analog. There are different combinations. So we're trying to look at new information technologies that might supplement that. And then, of course, working with the residents and the emergency programs, the best plan is preparing the residents themselves to be able to respond, self-evacuate, and ultimately will be able to communicate out of area. And that's where this push-to-talk communications, that's one of the first installations was with their emergency program. So they should be able to communicate with the province's emergency program, their headquarters, or out of area to another center. So hope I've answered.
Well, I've always been concerned about the landline connection.
Yep.
And all that,
Yep.
for telecommunications and for power.
That's right.
And, you
Yeah.
know, if some of the things are going on with some major earthquakes that would generate a tsunami, we're out of luck.
And in fact, you're just north of Tofino it's in the Cascadia subduction zone. So when the Juan de Fuca plate erupts there, the first wave will probably hit the island within 20 minutes. And so Tofino, again, it's being able to, the earthquake is really the warning for people for a nearshore event like that. But the problem is people self-evacuate, but then what do they do once they get to a safe area? How are they going to remain in communication with others, and particularly on the outside, to communicate their needs? Because in many cases they can't return. The event could last for at least 12 hours or more, just the tsunami event itself, and then somebody has to assess whether it's safe to go back. So, and you need, of course, reliable communication to do that. So a lot of the native First Nation communities are really very remote from there as well, and would remain isolated for a long time.
Oh, sorry.
Hopefully we'll have, please.
Okay. You mentioned some of the structural similarities between your early Australian network and essentially the ARPANET design.
Yes.
Was there possibly any information sharing or sharing of personnel between the two projects, or is it just that you both came up with the same, similar solutions to the same problem?
Well, the actual network design was started by, it was already started through a social networking volunteer kind of worldwide called FidoNet, which kind of ran parallel with ARPANET like in the early stages. And there was an organization that actually helped to set up an addressing scheme for store and forwarding. But also on the ARPANET side, at least as it became extended internationally, we did work with the people at the University of Melbourne who were the central contact point for the introduction of the internet into Australia. And they were just setting up an organization, so we did work with them. That's how we got our gateway. My center also, we got our internet access, and our arrangements were through them. But that was probably, I would say, informal. You know, there weren't formalized, but there were sort of there was a community. Volunteer, spontaneous, plus on the ARPANET side was more government institutional organizations, and some of us, I guess, were fortunate that we were able to participate in both, and we were able to have particularly in Canada, our university was very open to experimentation. We were one of the first in Canada to go to distributed networking, so. They were always interested in trying out something different. So we weren't burdened by a lot of we can't do this sort of thing. It was more of let's try and see how we can make this work. So I'm not sure if I've answered your question fully.
And one of the okay.
You're next.
Okay, it's nice talk. I think I enjoy really kind of following the history line of this issue. But there is a disasters could be by like natural disasters, which is from nature. But places which doesn't have maybe natural disasters, the human kind of like tend to create their own disasters, like either wars or like this. Do you think there is a similarity between a system that will also like evacuate people or help people during wars or like these things could kind of have what's really you think the similarity between these two things? I assume wars or like kind of several or more complicated than
Yeah. Well, certainly society today generally is relying on the same infrastructure and systems. I guess it comes down to the issue of access and how those systems are controlled and utilized. In Sri Lanka, the civil war was still on and was actually reaching its peak. So we had a number of villages that were participating in our project that some of them we actually physically could not go into. And actually when the army was doing their sweeps, they cut off all of the telecommunications services in the area. So there could have been a natural hazard occur at the same time, and there may not have been ways to even reach them. Even though the government was trying to set up new national arrangements for hazards, there were still times where that wouldn't happen. So
what I mean that is it possible kind of for the communities to maybe manage such kind of an hazard, for example, like warning systems, not having centralized something
yeah.
like
Well, this is
will maybe help
the
them?
Sri Lankan project was not government run. It was done through an NGO that set up a hub of its own just out of Colombo and worked with the villages. So they ended up as the exchange point with the communities. So it was their own system. So all of these ICTs actually were in a sense operated by the communities themselves, and even the organization of the World Space, the channel and everything, they had operated themselves. In a wartime situation, I think the security in the countries and others will target the telecommunications arrangements and try to control those as well. So even though it's possible to perhaps use these systems, whether or not there's that capability, how well they would be able to operate independently. I mean, you can set up your own broadband links between communities. In Sri Lanka, though, they weren't even allowed to use the two-way radios you can buy in a consumer store. So that was the problem. They could get the warning at the village level, but they couldn't communicate with other local villages by radio at that point. They weren't allowed to, even though the technology was readily available. It wasn't actually accessible to them for that reason. So.
Okay.
Seeing all the damage that occurred in those fires 10 years ago, I was curious, how are you, or what measures are you taking to protect your communication equipment? Are you able to find equipment that's...
Yeah. A lot of that infrastructure still can't be protected in terms of a lot of the fiber is still strung along poles. It's too expensive to try to bury the fiber. So the carriers have tried to put in more redundancy, so alternate routing and more diverse routing. So if service is cut in one area, it can be backfed from another location. There's more work being done in some cases to fire smart sites. So this time of year before the fire season or in autumn, to go in and clear the shrubbery and debris. I showed you the site with all the communications equipment. I mean, nobody had ever thought that fire would reach these in the past, and so, but to sustain that, we don't have no one's mandated to have to do that. So for the carriers, it's sort of in their best interest from a commercial perspective to try to keep things going. But we do have quite a good planning and coordination process, and we do share situational awareness now with all the utilities and everybody during events, and they work with us. We have strong liaison now, so if they get information about a hazard that could affect their infrastructure, they will tell us. But now that they're in a much more competitive environment, their companies also are less willing to disclose information about their infrastructure. So even state-owned utilities like our power are claiming it's proprietary information today. So I have a theory that the more imminent the disaster or risk, proportionally the greater the level of disclosure. But sometimes you have to be within a certain window before people start to open up and exchange information. It's still a lot about trust. Governments can't mandate some of this the way they may have been able to in the past. But at the same time, this infrastructure now increasingly is becoming so heavily dependent upon by society. It's not just for communication now. It underpins all of the social and economic and other services that we depend on. But the majority of it today is privately owned and operated too. So.
More specifically, after a disaster has occurred, like the equipment that you bring in, how do you protect it?
During the disaster, or
yeah,
well, we work under contract with our provincial government program, so we won't just be sent to an area. We will be part of a team, and in terms of we have a list of priorities, and the first is safety. So the first thing is an assessment. Is it safe to actually take the vehicle to a particular area? We also have to have a plan in place while we're there for ourselves. So if we were in a situation with a fire and we had to evacuate, there has to be a plan in place to evacuate us. But we wouldn't be there by ourselves. We're the communication support for the other emergency management teams that go in there. So same thing even for fuel and all of the things that we need to support our operations. That's part of the logistics support of the team that provides that for us. So, and there is a possibility we could lose the vehicle. And there's a strong case for making a lot of these vehicles and deploying them, but the reality is that it's very difficult to get governments and others to step up to invest in these things until after something's happened. That truck was built. I got the funding for that halfway through a 15-minute presentation with a government agency that had turned me down the year before. I'd come back after the fires with all the documentation. Halfway through the presentation, they said, "Stop, we surrender." First time that's ever happened, and so far it hasn't happened again for a long time. But and this is, I think, for yourselves. I mean, the unfortunate thing is that it takes events like this to generate interest on people's part, and sometimes it's hard to look at how to. I really don't want to use the word exploit, but sometimes there's a window that's there that is the only opportunity you're going to get, and. So in our case, we are spread across a number of different projects nationally and internationally. So, and we have a lot of self-determination, fortunately, with my lab and the work that we do. So we've learned to be adaptable as well.
In Christchurch, we're putting tsunami sirens. The problem with the sirens is they don't really tell you much information. It's just a noise. And,
yes.
And if you're a visitor, for example, you may not know what that noise means.
Yep.
So I'm just wondering, is there any work being done in adding content to that? Maybe a siren mixed with an audible dialogue saying you've got 3 seconds.
Tofino, putting in some sirens. Port Alberni, which is a community 60 kilometers inland from the coast that was damaged from the Alaskan earthquake, 1964, because the tsunami came up the channel. Their system, they do have sirens, but they're basically their audio, a lot like large loudspeaker systems, and in fact their warning is it's a spoken. There's a tone or something for the alert. an effective warning system really should have two components. One's an alert to get your attention, followed by some type of message. And often, even in communities, a siren may be the signal to turn to your radio station or to some other source. Today, of course, people are going to rely a lot more on the use of social media and that. And that's works where the systems are functional. But again, a lot of people don't realize that, for example, tweeting, I was mentioning earlier, there's a lot of metadata, a huge amount of metadata that wraps around a tweet. You think it's a short message, but the reality is about a 20-to-1 ratio of metadata that goes with that tweet. So every single tweet someone's pulling down on their device is being sucked off of a server coming through that network into the community. And so even though we're turning to these to supplement, we really need to, this is, I think, for yourselves, these are good areas to actually look at what are the impacts on our network infrastructure from these new ways of getting information out. On the other hand, you can target messages a lot better today. There are groups that are not at risk that may evacuate unnecessarily, certainly you can get the word out today in ways that we couldn't. But this is a problem. A lot of communities still want sirens, but not necessarily engage in an ongoing public education process so people understand what their use is.
I mean, one of the problems we have locally is the sirens, they test the sirens, but you don't know it's a test. So what do? You start running, or you
Yeah.
if you don't happen to get the information,
Yeah.
it says, so you know it's a test.
Yeah. In Port Alberni, they scheduled them at specific times. I think they have two of them, and one is midday. They've located them out of harm's way, but their schools are being moved back. One's right beside the school, so so people know it's at a specific time.
So like Sunday at 12 o'clock.
Yeah, I think there's I can't remember. They do it a couple times a month, and so it just doesn't happen. In the old days, we used to have air raid sirens, a network of them across the country, but they were never linked to the civil emergency program. In fact, they weren't allowed to. So there was a siren even in Port Alberni in 1964, but it wasn't used. It wasn't allowed to be used. There was no warning given to the people. But these were faulty too. They occasionally would go off. Some circuit would malfunction, and then half of them never did work because they were never maintained. So.
Have you looked at using drones at all as a means to accessing these areas that are now no longer accessible, or even as say a temporary point-to-point communications?
Yeah, we start to look at that. Well, of course, the military and others are using this technology a lot. Within our lab, we're looking to do some experimenting with it. I guess part of it is the looking at the communication links and whether you're trying to sort of do a store and gather and bring the data back, or whether you're trying to do real time. And then again in British Columbia, terrain and even if some people use GPS, and send it off somewhere, but in British Columbia, because of the mountains, the accuracy, you could very easily be piling it into a hillside or a treetop, especially depending on where you're trying to fly, as well as weather conditions and winds and all that sort of thing. So, but yeah, I think we'll see more of that, and we've also seen the use of balloons to be put up to provide for extending coverage and those sorts of things.
Yeah, because I can imagine if, say, like a fire did burn down all your communications, then setting up something like this temporarily would be beneficial.
Yeah. It's in our case, we've been fortunate. We've been able to access technologies as they've been emerging, either through the emergency management side or through the space exploration side. But being able to replicate this on a larger scale, our truck is, because it's stationed, in some ways it works against us, because it's stationed with the province's program. I think a lot of people assume now that we have the capabilities that we need because it's there. But the fact is that we need, in British Columbia, we need at least 3 more of those to be positioned, one on Vancouver Island and two other parts of the province so they could be deployed regionally. But then how do you support them? Who's responsible for that? In our case, we're able to keep it going, not so much through large grants, but we're able to combine our research, sort of the S&T side, with application. And the two have managed to really provide us with a means to sustain what we're doing. We don't get heaps of money for a lot of this, but it's enough to pay the bills. I have a $2,000 bill, a $2,000 a month bill for SATCOMs and telecoms that I don't get special grants for. We get compensated when we're deployed, and we have an arrangement where we'll ensure that we'll get a certain amount of deployment. But for municipalities or other authorities, they have to argue that this is something that should be supported out of their baseline funding quite often. And so I think universities also, I think can play quite a supportive role. I mean, I know that, during your earthquake crisis too, just the volunteer army and all the work that was done was really, I'd say, setting a new standard worldwide.
All right, so if there's no more questions, we'll give another round of applause.